Okay, so today we're talking about coterminal angles is one thing. It's about worksheet 4.3, number 1. All right, so if I had you do sine of 30, I know you know that one. It comes out to 1/2, all right, or 0.5. What about sine of 90? I think we just had you do that one. What did it come out to? 1. So sine went from a small number to a little bit bigger number. Do you think sine's just going to keep on going up? Well, let's find out. Do sine of, what would this one be? Like 120, 130, something like that. Let's do 120. Sine of 120. 0.86, it went back down again. All right, well, how about if we go to sine of 180? 0. So sine went up to 1, but then now it's starting to go back down to 0. What do you think is going to happen when we go past 180? Think it's going to go back up again? Let's find out. Do sine of 220. Sine of 220. What do you get? It's negative. Why did sine go up to 1 and then go back down to 0 and now it's negative? Because if you look at the graph of sine, that's what sine does. Have you ever thought about this? Sine goes like this. Sine goes up to 1 and then back down to 0, and then it goes down to -1, and then it goes back to 0, and then it goes back up to 1. You get what I'm saying? Sine oscillates between the highest it ever is 1, and the lowest it ever is -1. Okay, now another way we could say that is its range is between -1 and 1. All right, so now, as you're going around that circle, do you get that sine isn't always positive? When we just figured out that answer down in here, sine was negative. And sine's going to stay negative the whole time it's down here. And when it hits 0 again, what is sine of 0? Try it. Type in sine of 0. Sine of 0 is 0. Because why? Because if you look at the graph of it, it's back to, when it hits there, it's going back right there. It hits 0 again. All right? Or it starts right here at 0. All right, so what I'm trying to get across to you is that sine isn't always positive. Sine is positive when you're in here, and all the way up to, it's still positive there, it'd be +1, it's still positive all the way over here, but sine will be negative down in these zones. And you've got to keep track of all of the different places where sine is positive and negative, and cosine being positive and negative, and tangent being positive and negative. We've got a neato way for you to remember that. And it goes like this. This is the part where you take some notes. It is all students take calc. It's a dumb little saying. It's really, really handy. Because it tells you where all of the sine, cosine, and tangent come out positive. Next to this A, please write all are positive, because all sine, cosine, and tangent of any of those numbers in there, like +60 degrees or +80 degrees, they're always going to come out positive. Take a guess what this one means. Sine is positive. Well, what about the other ones? They're negative. So the only one in this zone, if you're in here, and you're over here, only sine would be positive. Cosine and tangent would be negative. All right, so the way I'd have you write that in your notes is sine is positive. Take a wild guess what the T means. Tangent is what? Positive. And the last one is cosine is positive. So if you can remember, all students take calc, and that we start here and you move to the left. It's like the same way you do the quadrants. Quadrant 1, 2, 3, 4. Remember that? It's that way. All students take calc. You're going to write that for yourself like a zillion times, because there's going to be a lot of complicated problems where they're going to say the sine of this function is negative. Well, right there you know that you must be in the 3rd or the 4th quadrant. If sine is negative, you must be down here or in here. And then they're going to say, and by the way, cosine is positive. Well then, if cosine is positive, cosine's only positive here and here, but sine's only positive here and here. So I was saying sine was negative. Okay, so sine is negative here and here. And where is cosine positive and sine negative? In there. So you'd be able to give an answer like, oh, that must be between 0 and negative pi over 2 in this little zone right here. Or you could say between 3 pi over 2 and 2 pi. In this little zone is where sine is negative and cosine is positive. All right, I jumped ahead there, so that might have blown some of your minds, but the main point is this. You're going to be expected to know where, in which quadrants is sine positive, and I think we got that straight. Sine is positive here and here. You don't have to know all the other ones, too. So we do that with this all students take calc deal. All right, so I'm going to ask you this. Where is sine positive? Where is the cosine negative? And the way I want you to answer is between 0 and 2 pi or something like that, which would mean everywhere. All right, so tell me, where's sine positive and where's cosine negative? Give it a shot. Just look at your little all students take calc dealy, Bob. Figure out where sine is positive. So degree sine is positive in this zone and in this zone. So wouldn't it be safe to say between 0 and what? Pi. If you wrote out two separate zones, that's okay. But between 0 and pi, sine is positive. Where is cosine negative? Well, if I go all students take calc. Where's cosine negative? Well, it's certainly not here because that's the point, is that cosine's positive there. And everything's positive here. So cosine must be negative in this little zone and this little zone. That would be between, what's that spot right there? Pi over 2 and what's that spot? 3 pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay, so between pi over 2 and 3 pi over 2. It's a 3 pi. All right. I think you're starting to get that. That's good. Next thing is coterminal angles. You ever heard of cohabitating? Just people live in the same spot. Okay? Co means like you share the same. Habitation. Cohabitate. All right, well, how about coterminal? Coterminal angles means that they're sharing the same spot. So if I have a circle and try that here. There. I have the third one. There. Now this one is now coterminal with the purple one. The blue one and the purple one are now coterminal in the same spot. The point is, that's at pi over 2 up here. Is there another way I could get to pi over 2? Yeah, I could go the other way. You can take this and go negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2. The point is, the pi over 2, which is where we were in the first place, and negative 3 pi over 2 end up in the same spot. So coterminal. Okay, they're just angles that end up in the same spot. Is there another way to get there? Oh, yes, there is. I could go like this. Start here. I could go past it. That's 1 pi over 2. 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So pi over 2 and 5 pi over 2 are in the exact same spot. Okay? So they're coterminal. Another way to think of that is, I just added 360 to it. You know what I mean? Like, let's say I had something that was at, let's put them both back down here for a second. Whoa, let me do that maneuver. Come on. There we go. Okay. Let's say I was here at 20 degrees. Do you get that I could say 360 plus 20 would be 380 in the exact same spot? Because I go there, which is 20, plus another 360. 360 plus 20, 380. So 20 degrees. Same exact place. All right, that's called coterminal. Next kind of topic that you have to understand is, let's say that I have a point. You know what? I'm going to stick with my circle plane. Get faster at making this. Okay. Let's say I had a spot right here. That's supposed to be a 45-degree angle. Okay. If I'm at that spot, do you get that this point right here would be something comma something, and if it's truly a 45-degree angle, do you get that the numbers are these sides right here, that side, and that side, and that if it's really a 45-degree angle, those blue lines would have to be the same? Do you get that that point could be 1 comma 1? Because this is 1 and this is 1. And if it was 1 comma 1, couldn't you figure out the other side then? A squared, b squared, c squared. 1 squared is 1. 1 squared is 1. Adds up to 2. Square root of 2. And hey, that's one I know. 1 square root of 2. Remember? All right, so a lot of times they'll give you one of these. And they'll say, now, you're at the point -2 comma 2. Because if this is where the x and y axis is like that, that's the point -2 comma 2. Didn't they effectively just tell you two sides of the triangle? I just told you that that and that are -2 and 2. Now, it's important to understand that the triangle can't really have negative side lengths, but we're talking about going to the left. That's why we got to call this -2. Okay, so technically, the length of that side is 2. The negative is telling us the direction. Okay, so then if that's -2 and that's -2, what's this side right there? Smart enough to do that? 2 roots of 2. Right. If you're not, what you can do is this. What's 2 squared? 4. What's 2 squared? 4. Put 4 and 4 together makes 8. What's the square root of 8? Happens to be 2 roots of 2. All right. So let's say I gave you the point. Let's give you one that's on the worksheet here. 4 comma -3. Draw yourself a picture. Put 4 comma -3 on it. And then make a little triangle, because it's all about triangles. You know, they say that life is all about circles. It's the circle of life. But trig is all about triangles. So if I just give you a point, I really gave you a triangle. Because 4 comma 3, let's go over 4, down 3, dot, and I just gave you a 4, 3, and I don't know what, but I bet you could figure it out. 3, 4, 5 triangles, a comma. And 3 squared is 9, 4 squared is 16, 9 16 is 25, square root of 25 is 5. So really, I just gave you a 3, 4, 5 triangle. And of course, it's not just that simple. I mean, that I can teach you in just 2 seconds. The question would actually be, what are all 6 trigonometric functions of that angle? So that's really pretty easy. There's sine of it. And by the way, let's get this something over with. A lot of you wrote this on your test. You wrote sine is like 4/5. That makes no sense. You have to have an angle. If you said sine is 4/5, that's not right. You can't just write sine. Now, I didn't mark it wrong for this quiz, but I need you to know for the future, sine all by itself means nothing. You need sine of an angle is like 4/5 or whatever. Okay, so you never want to just write sine all by itself. In fact, this means sin, if you were naughty. It doesn't mean anything about math. Okay? Now you mean sine of theta, and that makes a fraction, and then that's something like half or whatever. Okay, but you have to have that little angle in there. Okay, so when you're doing your 6 trigonometric functions, it's sine of theta, cosine of theta, tangent of theta. You don't have to use theta, but we usually do. It's sort of like pi. Pi is a symbol. You wouldn't have to use pi for 3.14. We just typically do. Okay? You don't have to use m for slope, but we usually do. So theta is usually our good go-tos for the angle. So sine, cosine, and tangent of this triangle, sine from this perspective right here would be opposite over hypotenuse. Opposite is this one. Hypotenuse is this one. Would be 3/5. And cosine from this angle's perspective is adjacent over hypotenuse, 4/5. And tangent from this angle's perspective is opposite over adjacent, 3/4. How do I get the other ones? They're just the flippin' sisters. So, I want to move this chunk over. I don't even need all that stuff anymore. I'll bring that back. Back. There we go. Now, the flippin' sisters are sine is cosecant, cosecant, and this is secant, and this is cotangent. And again, writing them that way means nothing. It makes no sense. You do this. Then I can give an answer. And it's just a flip. Flip the 5/3 to, or 3/5 to 5/3, flip the 4/5 to 5/4, and what? Oh, weird. My brain totally knew what to do. My hand. 5/3, 5/3, 5/3. Okay. And then 4/5 changes to 5/4, and the last 3/4 changes to 4/3. I was on such a roll there. Okay, I think I got it right. Those are the 6 trigonometric functions. Once you have all 3 sides, it's really easy. Okay? All right. Today's one of these days where I just have a lot of little easy things to teach you. It's not that hard. Okay. You should be fine on that. Next part. I talked to you about positive and negative, right? What if I said I was between 0 and pi over 2? What will cosine be? And all I need to know is it positive or negative? Between 0 and pi over 2. That's in here. Well, yeah, everything's positive in there, right? That's an easy one. Okay, yes. Yes, I will pause right now and we'll do that. All right, so we're back from our little break there to go to lunch, and another kind of problem you'd be expected to do. If they just said cosine of 143, is it positive or negative? Well, I want you to sketch for a second where 143 is. Put that away or you're going to lose it. And once you got your picture drawn with 143 on it, then ask yourself, all students take calc. Is cosine positive there or negative there? Where's 143? Okay, 143 would be a little less than 180, so it'd be something like that. Is cosine positive there or negative there? All students take calc. Only sine is positive there, so therefore it's negative. It would be less than 0. It would be negative. Okay? All right. Next kind of question. It says, choose which could be a point on the terminal side of theta. All right, so that sounds really confusing. But here is an angle. Theta is 45. Sketch me that. Sketch 45. Now, I'm going to give you 3 choices on what one of the points, a point on that line could be. Do you have that sketch yet? All right. So it should look like this. Now I'm asking you about this point. Could it be this, this, or this? 3 comma root 2, 2 comma 2, or -1 comma -1. Which of those makes sense? Only one of them could possibly make sense. Yes, sir. Yep, 2 comma 2. Because where you are is positive and positive, like it's going to the right and up. So it can't be that one. It can't be that they're different sizes either, right? Because if it's a 45-degree angle, you know it's a 1, 1 square root of 2 type triangle, right? So it could be 2 and 2, though. It could be that one. All right. Next kind of... That's all the kind of questions. So now, I want to hand out the worksheet, and then I will do some with you. I'm going to pause for a second while I hand those up. Okay, now I got them handed out. Here we go. Number 1. Identify the one angle that is not coterminal with the others. In other words, everything's coterminal except one thing. So you know where 150 is about? It's about here. Okay? Almost all of them are right there. But only one of them is not right there. You figure out which one does not end up being right there. I'm not going to say it. You can figure that out. All right, let's move on to problem number 3. Number 3. It's got a little drawing for you with the thing up like this, and it says 1 or -1, comma 2 is right there. Didn't they just tell you 2 sides? Yes, they did. They just told you an X and a Y. You get how that's X and that's Y? X is -1, Y is 2. There we go. I got 2 of my sides. But I need all 3 sides to be able to find sine and cosine and tangent and stuff. So, let's do a squared plus b squared equals c squared and figure out that last one. So, 2 squared is 4, 1 squared is 1, 1 and the 4 makes 5, so what is it? Square root of 5. And now you just have to go, now I know this is a pain, that's why I'm going to have you skip a couple of these. You got to do every single one of the angles, all 6 trigonometric functions of theta. So you got to go off to the side and write this: sine theta, cosine theta, tangent theta. Notice I'm putting a theta after each one. And then you need the sister ones: CSC theta, SEC theta, those are called secant and cosecant, and then cotangent theta. There. You're going to have to write that for all these problems, except you may skip problem 5 and 6 because these take so long to write out. All right. So let's actually just do one of them then. What is sine of theta? Well, this is theta. Theta is the inside angle there. And sine is opposite over hypotenuse. Opposite side's 2. Hypotenuse is square root of 5. So 2 over square root of 5. And then the sister of it is really super easy. You just flip it. 5 over 2. There we go. That's how you do that kind. Now, I know you're not done with it, but force yourself to move on with me because I'm going to give you some more free help here. Flip to the next page. Next problem, 7. It says, point P on the terminal side of angle theta. Evaluate 6 trigonometric functions for theta. Same deal where there's like so many parts to the problem. You may skip problems 11 and 12. Cross them off because you're going to have to do 6 for each one of these. So let's do number 7. 3 comma 4. How do you do that? Well, where's 3 comma 4? Over 3, up 4. Put it out right there. That's at 3 comma 4. By telling you that, they just told you 2 sides. They told you this side is 3, and they told you that side is 4. And if you know your triangles well, you'd know the next side is 5, 3, 4, 5. And once you know that, you can just go sine of that angle, cosine of that angle, tangent of that angle, and then the sisters for it. CSC of that angle, etc. Remember, don't have just sine. It means nothing. It's sine of theta. Cosine of theta. Tangent theta. Same. All right. Next kind of problem. Number 13. That's too easy. Let's move on to 15. Number 15. It asks about the interval from pi to 3 pi over 2. I know these can be a little bit confusing when you first think about it, but if you know it's a circle we're talking about, like this, and I always have this kind of deal going on. Where is pi? It's right there. Where is 3 pi over 2? Well, I'd want to know where pi over 2 is first. There's pi over 2, 2 pi over 2, 3 pi over 2. So from pi, which is here, the 3 pi over 2 is here, it's like this little zone right there. What they're asking about is in that zone, what do they want to know? What's it say? Is it positive or negative? Okay, so is sine positive or negative in here? Remember, for sine, is it positive or negative in there? Sine's negative in there. And then they want to know about cosine and tangent. So again, the zone we're talking about is from here to here. And that little zone right there, they just want to know is sine, what about sine? It's negative. What about cosine? And what about tangent? All right, good. Okay, I think you get the idea on that kind. And now flip to the back page. We just practiced one like number 17. We actually did cosine of 143. Do you remember if it ended up positive or negative? Cosine of 143. 143 would be right. 143 would be like in here somewhere. And would cosine be negative or positive? Because all students take calc tells me that the only thing that's positive over there is sine. So if you're in here and you're cosine, you're negative. All right. And then the last one is, which of these points could work? It's not a 3-part question. It's a multiple choice question. It's either A or B or C. Okay? All right. That's how you do it. You got some time to work. If you want to see your test over again, I'd be glad to give them back to you.